The Woodville Karst Plain Project has been working for over 30 years to explore and survey the many underwater caves beneath Leon and Wakulla counties south of Tallahassee, Florida. The WKPP has compiled their own survey data together with data from other explorers dating back more than 50 years. Today, surveyed underwater cave systems within the Woodville Karst Plain total more than 60 miles, with local, state, and federal entities factoring in the location of these underground rivers more than ever before. As more entities make use of this data, the importance of data integrity, including accuracy, targeted resurvey of legacy data, new technologies to enhance accuracy, and improved communication to stakeholders on data availability cannot be overstated. An underwater survey begins with accurate location mapping at the surface entrance. Using a combination of GPS points and ArcGIS map locations, the surface location of the survey is determined. Next, the cave divers install a pre-knotted nylon, non-stretchable guideline within the cave passageway. This guideline is permanently installed by affixing it to the walls and floor of the cave, with emphasis placed on aligning the guideline as closely as possible with the structure of the cave passageway. Once the guideline is run from the surface location and affixed within the cave, the divers survey the line. At each survey station, they record the distance between fixed station by counting the knots in the line, which are every 10 feet. Next, the divers record the azimuth or magnetic heading of the guideline, followed by the depth and any notes about the cave. They use an underwater notebook and pencil to record the data on specially made underwater paper that will not fade or deteriorate over time. Once the divers are back at the surface following their dive, they enter the survey data and notes into a commercially available computer survey program. The program plots the data from the known surface location. Upon final quality review, including adjustments for magnetic declination by the WKPP team cartographer, the data is then transferred to an ArcGIS database. The data is then compiled with existing data and can be placed over satellite images, aerial photos, LiDAR maps, topo maps, or any other shapefiles. The survey is then exported to a program like Google Earth to easily view on a phone or tablet. In all geologic or engineering surveys, there is always inherent limitations with exactness and accuracy that must be incorporated. These are usually due to instrument or sensor shortcomings, survey methodology, or even human error. In the case of underwater cave surveys, these are no different. An inherent drift or error is calculated over the distance of the survey, resulting in a worst-case adjustment that can be applied to the survey points to compensate for instrument or survey methodology. In cases where the surface locations are long distances from one another due to lack of sinkholes, additional fixed points can enhance the accuracy of the survey. The WKPP uses an instrument called a cave radio locator, or CRL, to enhance survey accuracy at predetermined points. The team cartographer determines the optimal location for deployment of the CRL within the cave system, usually a distinguishable location in the cave or a junction where multiple passageways intersect. The dive team then transports the battery-powered low-frequency transmitter to that location and activates the transmitter, emitting a unique electromagnetic signal through the rock layers above the cave. The surface team uses a special receiver to determine the exact location on the surface of the signal and records the GPS location. This fixed GPS point from the CRL is now recorded into the survey database along with underwater survey data obtained by the divers. The underwater survey is then corrected through algorithms to this fixed GPS point, reducing error propagation and thus constraining the survey's error. This combination of manual survey and radio locations reduces drift error and enhances survey and map accuracy of the underwater caves of the area. The results are accurate enough that 4 wells up to 300 feet deep were drilled into the underwater passages of Wakulla Spring Cave, and each well was precisely on target. The wells were used to directly connect data cables and water sampling tubes to specialized scientific instruments positioned in the cave. The instruments record temperature, conductivity, and water flow measurements for the Florida Department of Environmental Protection, Northwest Florida Water Management District, and Florida State University. Despite there being no certified standard for underwater cave survey, the cave divers of the Woodville Karst Plain Project have developed and refined the process for capturing high-quality data from this unique environment.